In some cases, if there is a problem with inflammation in the body, and again, we're going to get to that, it causes the buildup of blood clots. But let me move on to the next one. I show this picture here because this is probably the key thing when it comes to stroke. It's a cessation in some part of the brain due to a couple of things that could, like we mentioned. In Alzheimer's disease, let's say, for instance, with the brain, what they're finding out is that the blood flow to certain parts of the brain is diminished, and also the other thing they're finding out is that there's a lot more free radical damage in people who eventually develop Alzheimer's disease. They don't have enough protection with antioxidants. So there's this big thing about using antioxidants to help protect your brain. Some hormonal supplements, and there's a lot of controversy where hormonal supplements are concerned, and that's why I always recommend that we start first of all with the building blocks for those hormones rather than the hormones themselves, because your body knows what to do with it. If you just come from outside and just introduce a fully formed hormone, it doesn't matter. Yeah, it's natural is a lot better than synthetic, obviously, but you're still introducing a fully formed hormone. It can knock your body systems out of balance, and therefore it's really important to give the body what it needs. So the body, because the body has its own intelligence, it will be able to take care of the problem, to be able to use the building blocks in a way that does not upset the balance. Okay, the key thing, and I got this from my slide on the human brain. Some of you might have listened to my class our class on the human brain. But the two main things with the brain, again, are the perfusion, blood flow, and, of course, the connection between the nerves. The nerves have to connect and communicate with each other in order to function. Well, of course, without blood flow, you're not really going to say much about communication either. So it's very, very important to ensure that there is adequate blood flow to the brain as well as to other tissues too. Okay, another thing we kind of noticed, as I was talking about this, and this is an interesting factor, what they're finding out, folks, with cancer is that even cancer cells, because they're cells, albeit unnatural, terrible, nasty cells, but cancer cells also need a blood supply. And here's what they found out, and this is coming from a doctor who was initially a surgeon, and he started noticing this, and he began to develop a drug that would stop it. What they began to realize was that the cancer cells themselves actually secrete substances which draw blood, which cause the formation of new blood vessels that will feed the cancer cells, and these cancer cells actually secrete these chemicals in a much more effective way than normal cells do, and so they kind of draw blood supply to themselves. So one of the things that they started looking at was creating drugs that would disrupt the cancer cell's ability to form blood supplies and to form its blood supplies. Anyway, this just underscores the importance for survival of any cell in the body, the importance of cellular perfusion. All right, we talked about the heart, we talked about generalized perfusion. Let's talk about the arteries themselves, and we're going to move on to the veins next. Here's a cross-section again of a typical artery. Now, the arteries are different from the veins in that they have a much thicker muscular inner layer, middle layer. This is actually the middle layer. The inner layer is this called the endothelium. That's what gets damaged, and that's what needs to be healed. These, of course, are the blood vessels. The problem in hypertension, in some cases, it's actually due to buildup of plaque. In some cases, it's actually due to a thickening of this muscle. And what happens if this lumen becomes narrow? It's kind of like when you think about a hose. When you're squirting, you open the tap, the faucet, and you're spraying the hose. You're spraying the garden. If you narrow the outflow by putting your thumb over it, well, the pressure comes out a lot more, right?
Right.
If you take your thumb off, of course, everybody has sprinklers here, so we probably wouldn't relate to that, but But
we do know what hoses are.
Okay, good. Okay. So what happens in hypertension many times is that this wall becomes a lot thicker, therefore narrowing the lumen of this blood vessel, and therefore the pressure increases. And a lot of factors that attribute to that. Hormones, like we mentioned, play a part, but also certain chemicals, certain other factors. Well, okay, we'll get to that, like I said. Let's talk about the veins real quick. The veins do not have muscles like the arteries do, and so they have to rely on contraction, movement of the muscles around the veins to push the blood. These arrows actually should be pointing upwards, but they're pointing downwards. So just assume that's kind of like down on your head or something, and then you'll be able to understand what I'm talking about. But when the vein is the blood moves better through the veins when the muscles are contracting. That's why it is so important for people to exercise, because as you exercise, blood moves better. The same thing with the lymphatic tissue. Blood circulation is improved when you're using your legs, using your limbs. When you're sedentary or when you're stationary, that isn't too good because it predisposes to a risk of stasis of the blood staying still and you not being able to function and could predispose to disease. Here's another picture showing both the arteries, which are in red. Veins are usually in green because of oxygen. It's really oxygen that makes, did I say green? I meant blue, excuse me. It's oxygen that makes the arteries bright red, and the lack of oxygen that gives them a bluish tinge. Okay, let's talk about blood pressure. Again, back to that same picture. Blood pressure is controlled by a number of centers. Of course, the most important centers are, of course, in the brain. Two parts, the medulla and the hypothalamus. And these two represent the two main ways information is transmitted around the body. The medulla, which is really that's the lowest part of the brain. It's at the part where your skull meets your neck. It's hidden right there. I actually had a friend who had neurosurgery. She's a doctor too, for a growth in her medulla. That is scary because the medulla is what controls blood pressure, it controls heart rate, it controls respiration, it controls all those subconscious involuntary things that you're doing. So if the medulla is damaged, there isn't much to say. She was really fortunate, and they were able to remove the tumor completely. And gosh, I mean, when I first heard it, I was scared. But she's okay. She's recovering. I wish I could get her on nutrients too, because that would definitely help her recovery. But anyway, the medulla receives a lot of information, primarily from nervous tissue, from the nervous system, the sympathetic nervous system, the parasympathetic nervous system. The hypothalamus that we talk about a lot actually receives most of its information from the hormones in the body. And these hormones there are about 200 different hormones in the body, and they're constantly sending information to the brain, letting it know what is going on. Now, in this particular case, we're talking about blood pressure, how blood pressure is controlled. So there are centers in the brain. There also is a center, or there are receptors in the carotid artery. That's what supplies the main artery that supplies the brain. It senses the amount of blood pressure that's going, and the pressure at which the blood is flowing. It sends signals to the brain too. Same thing at the aortic arch. Same thing in the kidneys. But the kidneys also regulate how much fluid there is in the body. So if there's too much fluid, for instance, that could predispose to high blood pressure. So the kidneys increase their excretion of water into the bladder and out the body to reduce the amount of blood pressure. If there is not enough fluid, if the blood pressure is not high enough or normal, and on average 140 over 90 is the higher limit of normal. Anything above that is what is counted as borderline hypertension and going on to hypertension. So if the kidney sense that the blood pressure is low, what does it do? It conserves water and does not excrete it like it should. So this whole system is a very finely tuned system that is controlled, as always, by the brain. So again, the key is information transfer. The key is always communication. We've said this over and over again in our classes. We can't